Before Earth had form, before space had direction, before time had meaning, there was nothing. No light, no stars, no breaths of wind, just a silence so dense it could not even be called silence. And then, in an instant, the universe ignited. A flash tore open the void. Space stretched in every direction. Energy flooded the newborn cosmos. From that first breath, matter began to assemble. Simple at first: hydrogen, helium, the alphabet from which all things would later be written. But simplicity could not last. In the darkness, the first stars awakened. They were enormous, unpredictable, violent. They burned with such intensity that inside their cores, new elements were forged. Carbon for future forests, oxygen for future skies, iron for future planets. When these ancient stars died, they did not fade. They exploded. They scattered their ashes across the universe. Ashes that would become mountains, oceans, and eventually, creatures capable of asking where they came from. One cloud of those ashes, cold and wide, began to collapse under its own weight. At its center, a new star caught fire, our young sun. Around it, a thin disk of dust and ice flattened and rotated, a cosmic workshop spinning silently in space. Inside that disk, the dust did not remain dust. Grains clumped together, pebbles collided and fused, rocks gathered into larger bodies. Every collision was heat, noise, creation. And slowly, without witnesses, one of these growing worlds became the seed of Earth. Heavy metals sank toward its core, forming a molten heart of iron and nickel. Lighter materials floated upward, forming a fragile crust, the first skin of the planet. This separation created two miracles: a metallic core capable of generating a magnetic shield, and a rocky surface that could one day hold oceans, continents, and life. But Earth was not finished. Its story was missing one final blow, one last collision that would redefine everything. And that collision was already on its way. It arrived not as a threat, but as a companion born on the wrong path. A young, molten world the size of Mars, now drifting into Earth's orbit. We call it Theia. But what it truly was destiny. The collision was not a crash. It was a cosmic sculpting. Theia struck Earth at an angle, not head-on, peeling away mountains of molten rock, vaporizing entire layers of Earth's early crust, and throwing a glowing arc of debris into the sky. That arc became a ring. And from that ring, under the quiet force of gravity, a second world emerged. The Moon. Newborn, it was colossal, filling half the night sky, a blazing red orb hovering impossibly close. Its presence would become Earth's stabilizer, its guardian, its timekeeper. Without the Moon, Earth's axis would swing like an unbalanced spinning top, creating seasons too chaotic for life to ever endure. With the Moon, the planet found rhythm. The tides obeyed a pattern. The climate learned consistency. Order slowly began to rise from cosmic violence. But in that era of fire, Earth's surface was still an ocean of magma. Volcanoes split the crust again and again, breathing out clouds of carbon dioxide, nitrogen, sulfur, and countless other gases that built a thick, suffocating atmosphere. The heat was unimaginable, generated by violent impacts, by the compression of matter, by the decay of radioactive elements deep within. Yet beneath the chaos, Earth was cooling. Lava seas hardened into dark plates, only to be shattered and remade by new impacts. The crust thickened, retreated, grew again. It was destruction and creation, intertwined in a single endless cycle. And then came water. When temperatures finally dropped, the steam in the atmosphere condensed. Rain began to fall, not for days, not for years, But for centuries upon centuries, rain hammered the glowing rock, sizzled into vapor, rose back into the sky, and fell again. Only after ages did it remain on the surface. The first oceans formed. They were not blue, not peaceful, not familiar. They were dense, mineral-rich, almost metallic in color. But they were oceans in every sense. And within them, lightning sparked chemical reactions, minerals dissolved into complex mixtures, and something extraordinary became possible. Earth, for the first time, was more than fire and stone. It had become a laboratory. And within that laboratory, a quiet revolution was beginning, one that would lead to the first fragile seeds of life. The early Earth was no paradise. It was a world battered by debris left over from the birth of the solar system. Asteroids rained down for millions of years, sometimes vaporizing entire sections of ocean, sometimes cracking the crust open like thin ice. Yet every time destruction swept across the surface, the planet rebuilt itself. Oceans returned, rocks solidified, chemistry resumed. This rhythm, impact, cooling, renewal, was not a setback. It was preparation. Deep beneath the crust, Earth's metallic core spun in liquid motion, creating a magnetic shield. Invisible, but essential. It deflected the deadly solar wind, allowing the atmosphere to remain in place. Without that shield, our world would have been stripped bare, a silent desert drifting through space. But because the shield held, water, heat, minerals, and energy could work together on the surface, and it was in places carved by heat and tides that the first steps toward life began. On volcanic shores, boiling pools shimmered with dissolved chemicals. As tides driven by the newborn moon rose and fell with astonishing force, they concentrated ingredients in the same places, at the same rhythms, day after ancient day. In the deep sea, hydrothermal vents roared, towers of superheated water rich in metals and sulfur. These places, too, became crucibles where energy bled into chemistry, and chemistry learned persistence. Everywhere on this young planet, molecules collided, broke apart, reassembled, failed, and tried again. At first, these reactions were nothing more than chemical coincidences, simple chains forming and dissolving, without design or purpose. But after countless cycles of wetting, drying, heating, and cooling, some of those chains began to form bubbles, microscopic droplets surrounded by fragile skins. Inside these droplets, chemistry could concentrate, accelerate, stabilize. It was not yet life, but it was the beginning of the idea of life. Over immense spans of time, in trillions upon trillions of tiny experiments, some droplets discovered a remarkable trick. They could make rough copies of the molecules inside them. The copies were imperfect. Mistakes happened constantly, but a few mistakes helped the droplets hold together longer, or copy themselves faster, or capture energy more efficiently. Those droplets survived. The others did not. There was no intention, no plan, no foresight, only selection. What endured remained. What failed vanished. This pattern, a boundary that protects, a way to harness energy, a system of copying with variation, is the root of everything that would follow. Eventually, some of these early systems learned to use sunlight. It was the greatest innovation in the history of life. Using light, they transformed carbon dioxide and water into energy and structure, a process we now call photosynthesis. The waste product of this reaction was oxygen. At first, the oceans swallowed the oxygen. It reacted with dissolved iron, settling onto the seafloor as layers of rusted stone. But as time passed, the iron ran out. The oxygen remained. Slowly, invisibly, the atmosphere began to change. Oxygen accumulated, And with it came a protective ozone shield high in the sky, a shield that filtered out lethal radiation. For the first time, the surface of Earth was no longer deadly. And within these tiny cells, the new abundance of energy allowed repair, growth, and complexity to rise beyond anything that had come before. Life had not yet conquered the world, but now, for the first time, it could. Oxygen changed everything. For many early cells, it was poison. Entire lineages vanished as the air shifted around them. But a few discovered how to use this new, powerful molecule. With oxygen, they could extract far more energy from food, enough to repair themselves better, grow larger, and explore environments their ancestors could never survive. This was the beginning of complexity. In the open oceans, some cells merged with others capable of producing energy. What started as a temporary arrangement became a permanent alliance. The host provided protection. The guest provided power. Together, they became something new. The first complex cells, factories of life, with compartments, storage, and the machinery to support greater ambitions. With more energy available, cooperation became evolution's next experiment. Some cells stayed together after dividing, one carrying nutrients, one offering structure, one handling movement, one detecting light or pressure. These early partnerships were the first bodies. From here, life diversified faster than ever before. Soft, simple organisms carpeted the seafloor, filtering food from the water. Then came predators, creatures that hunted other creatures, forcing innovations on both sides. Movement became essential. Muscles appeared, senses sharpened. Light-sensitive spots evolved into curved pits, then into chambers, then into the first eyes. Windows that opened entirely new worlds. Shells hardened, spines formed, bodies elongated, split, segmented, coordinated. Earth's oceans became a battlefield and a nursery, overflowing with shapes the planet had never seen. As continents drifted and collided, shallow waters formed along their edges. Rivers fed nutrients into these coastal zones, creating ecosystems dense with food and opportunity. And in these places, the next great leap occurred. Plants began to creep out of the water, bringing their sunlight harvesting machinery with them. Soon, the land was no longer barren rock, but dotted with green. Animals followed. At first, they emerged only briefly. Fish gulping air when pools dried, their fins pushing against mud. Those that stayed longest evolved sacs of air, stronger bones, joints that could bear weight, necks that could turn independently of the body. The boundary between sea and land became a pathway. One traveled slowly, clumsily, but relentlessly. Eventually, some creatures solved the final problem: their eggs. By protecting them in hard, self-contained shells, they no longer needed to return to water to reproduce. Life had truly claimed the land. Mountains rose. Rivers carved valleys. Continents merged and separated again. Through it all, living things adapted, expanded, and filled every corner where energy and stability could be found. From a universe born in light, from a cloud of star dust, from an ocean of magma, from drops of chemistry that learned to hold memory, life emerged and refused to surrender. And one day, billions of years later, some of those descendants would look at the sky, touch stones older than imagination, and ask how it all began. We tell this story because it is ours, because every breath, every thought, every step we take is rooted in that ancient journey. If this story awakens something inside you, stay with us. Like, share, and subscribe for more untold histories of our world. Here on Legacy Untold, where the past speaks again.